Hi class, in lesson 1.3 we are going to be investigating prime and composite numbers. Learning targets for today, we will distinguish between prime and composite numbers and identify and use the multiplicative identity. Key terms to look for during lesson 1.3, prime and composite numbers and multiplicative identity. I'm going to read the lesson introduction on page 31 in order to build a little background knowledge to start problem 1 on the next page for lesson 1.3. So if you can follow along as I'm reading this, it says that you may have heard that during the time of Columbus, many people believed that the earth was flat. However, some historians think that this is a misconception. These historians do make a good point. Greek mathematician, geographer, and astronomer Eratosthenes has been credited as the first person to calculate the circumference of the earth. He made this calculation roughly around 240 BC, thousands of years before Columbus's time. If you remember, circumference is the distance around a circle. Therefore, even back then, people assumed that the earth was round. Let's take a look at problem 1 and the game that you are going to be playing for starting out lesson 1.3. Up at the top it says that a sieve is an old tool that is used to separate small particles from larger particles and is usually a box with a screen for a bottom that allows the smaller pieces to fall through. If you can kind of imagine a skimmer that we use for a swimming pool, I think that would be something similar. The sieve of Eratosthenes screens out all of the composite numbers and leaves only the prime numbers. Prime numbers are numbers greater than 1 with exactly two distinct factors, 1 and the number itself. Composite numbers are numbers that have more than two distinct factors. You and your group members or your partner that you're working with will use the sieve of Eratosthenes to determine all of the prime numbers up to 100. So if you can take a look, we see that the figure shows the first 100 numbers written in numerical order in an array. What I would like you to do to get started today with your group members is answer questions 1 through 5 down at the bottom of page 32. Please follow all of the directions carefully in working with the sieve of Eratosthenes. After following all of these steps 1 through 5, here's what your figure should look like after you are done. If we look at number 5 and list all of the prime numbers, we should have 25 total numbers that we have listed: 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. Let's turn to the top of page 33, and with your group members, I would like you to do number 6, 7, 9, and 10. We are skipping number 8. I put an X through it, so 6, 7, 9, and 10 with your group members. If we take a look at number 6, only one even number is prime. 2 is going to be the only even number that is prime from our list. Number 7, no, it is not possible because every even number greater than 2 is going to be divisible by 2 or has 2 as a factor, and that would make it a composite number. Number 9, no. All odd numbers are not going to be prime because some odd numbers have factors other than 1 and themselves. For example, the number 9 has factors 1, 3, and 9. Therefore, it would not be a prime number. If you think about the number 15, 1, 3, 5, 15, that would make it a composite number as well. So no for number 9. For number 10, you had to go back and take a look at your Speedy Builders problem from the previous lesson, and the prime numbers from the area models that you created were 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. These numbers, if you noticed, are always going to have only one area model because the only factors of a prime number are the number 1 and the number itself. There are no other ways that you can make other area models for these prime numbers. We are going to take a look at the Talk the Talk activity today to finish off lesson 1.3. So if you look at page 34, we have a couple of bullet points up at the top. It says that the number 1 is neither prime nor composite, and we should know that the number 1 is a factor of every number. The number 1 is called the multiplicative identity. The multiplicative identity is the number 1. When it is multiplied by a second number, the product is always going to be the second number. And they have an example here that they show you 1 times 5 is going to be 5. 1 multiplied by that second number, which is 5, your product is 5. What I would like you to do to finish up for today is answer questions 1, 2, and 3 with your group members. If we take a look at number 1, the number 1 is not prime because it does not have two distinct factors, one in itself. It is not composite because it does not have more than two factors. 1 has only itself as a factor, so that is why it is neither prime nor composite. That's what you should have for your explanation. For number 2, all prime numbers have exactly two distinct factors, one in the number itself. And the characteristics for composite numbers, all composite numbers have more than two distinct factors. So keep that in mind when helping to distinguish between prime and composite numbers. That is going to do it for the lesson today on investigating with prime and composite numbers. Please let me know if you have any questions.